Hey guys, sorry for not being there again, but I wanted to make sure that you were able to get the notes for today. We're going to take a look at all the transformations we've talked about, both translations, left, right, up, down, and dilations, stretching vertically and horizontally, changing the amplitude and changing the period of trig functions. And we're going to put all those together into three equations and take a look at how we graph them. Again, nothing will have changed from the past 2 days. We are just putting all of the transformations into one equation. So the first equation we're going to look at is a sine function. We have the equation or the function y equals -1 plus 3 times sine of 2 times x plus 45 degrees. We want to graph one cycle of this. And so the first thing we're going to do is take a look at and identify all these characteristics. So the phase shift, we see x plus 45. The phase shift is going to be moving us left 45 degrees. We have a vertical shift of -1. So that's our vertical shift right there, -1. That is also going to be our midline. Remember, our midline will help us figure out our range. And then our amplitude, we have a plus 3 times sine. So our amplitude is just going to be +3. Remember, the amplitude is always positive. And then for the period, we know that normally the period of a sine function is 360 degrees. Well, again, remember, we know x always lies. So right here it says we're multiplying by 2. That means we're really dividing by 2. So we're going to take the 360 degree period, divide it by 2. That tells us that our new period is 180 degrees. And we know that our domain is -infinity to infinity. And we know that the range can actually be found by using the midline and then adding or subtracting our amplitude. So if we know that our midline is -1 and then we subtract 3 from that, we would have -4. And if we add 3 to -1, we would get +2. So our range is going to be -4 to 2. Now, in order to graph this, remember, we're going to need to get our transformation or mapping notation. And then we're going to use the quadrantal angles, our nice 5 points for the sine function, in order to get our 5 new points for our graph. And so again, looking at what our mapping notation is, we need to figure out what's happening to the x values first. So the x values are moving left 45 degrees. They are also being divided by 2. So we're going to have 1/2 x, and then we're going to subtract 45 degrees. And then the y values, they are being multiplied by 3 by the amplitude. So that's the amplitude, so 3y, and then they're being moved down 1 unit. And so what we're going to do is take our 5x values and our 5y values and put them into our mapping notation and find out what our new points are. So 1/2 times 0 minus 45 is going to be -45. You have half of 90, that's 45. You're going to subtract 45 from that, you get 0. You have half of 180, that's 90. Then you're going to subtract 45 from that, you get 45. Half of 270 is going to be 135, and then you're going to subtract 45 from that, and you're going to get 90. And then finally, you're going to take half of 360, that's 180, and subtract 45 from that. That's going to give you 135 degrees. And so we have our 5x values. Now we need to get our y values. 3 times 0 is 0, minus 1 is -1. We're going to have 3 times 1, that's 1, minus 1, that's going to be 2. 45, the 45 degree one, so we have 0 times 3, that's going to be 0 minus 1 is -1. And then we're going to have -1 times 3 is -3 minus 1 is -4. And then we're going to, again, get -1. And so we have our 5 points that we need to put on our graph here. And so, if looking at this, I need to go from -45 to 135 on my x-axis. So, at this point, we kind of want to get to the point where we can figure out what we want our scale to be. I am going to make every 2 points, 45 degrees. So that gives us negative 45 degrees there, and this gives us positive 45 degrees there. Then we have 90 degrees right there, and then we're going to have 135 degrees right there. And so we go ahead and we place these points on our graph. So we have negative 45, negative 1 right there. We have 0 degrees and 2 right there. We have 45 and negative 1, which is right there. 90 and negative 4, which will be right there. And 135 and negative 1, which will be right there. And we're going to go ahead and connect our points with a smooth curve. And there's our sine graph that has had all these transformations done to it. And it only asks us to graph one cycle. So there we go. Again, remember, you're going to list out all of these characteristics, and then you want to come up with your mapping notation and take your quadrantal angles for the sine function and put them into your mapping notation to get your 5 new points. The next equation that we're going to look at is a cosine function. So again, this is very similar to what we did for sine. We're going to have, our equation is y equals 3 minus 2 times cosine of 1/2 times x minus 60 degrees. So again, our phase shift is going to be moving us to the right 60 degrees. Our vertical shift right here is going to be moving us up 3 units. The amplitude is positive 2. I know there's a negative sign there. That's telling us that there's a reflection. So we do need to maybe make note of it here that there's a reflection over the x-axis. And then we need to figure out our period. And so again, if we look at this, we have 1/2 times x minus 60. And so another way to write that is to write that as x minus 60 degrees divided by 2. So you notice we are dividing by 2 in the equation. And since x always lies, that means we're going to multiply by 2 here. So since the period of cosine is normally 360 degrees, we're going to multiply by 2. That gives us 720 degrees. So this cosine function in this graph is going to be stretched out horizontally. The domain, still negative infinity to infinity. And remember, the range is going to be, you look at your midline. So again, remember the number that is our vertical shift, that represents the midline. So our midline is at 3, and then we would add and subtract our amplitude. So we have 3 minus 2, that's 1, and then we have 3 plus 2, that's 5. So that gives us a minimum and maximum point or value. So again, with cosine, you're going to take the 5 quadrantal angles, and you're going to figure out what your mapping notation is and plug those 5 quadrantal angles into your mapping notation. So if we look at this, our x values are changing. We are multiplying them by 2, so we have 2x, and then we are moving them right 60 degrees. And then for our y values, we are reflecting over the x-axis. We are multiplying them by 2, and then we are going to add 3 to them. So we now have to figure out our new points. And you can see I kind of already have prepped us. We are going to have some rather big numbers here. 2 times 0 is 0. That gives us 60 after we add it. 90 times 2 is 180. 180 plus 60 is going to be 240. We are going to pull out a calculator here just since I'm recording this kind of late at night. My math might be a little off. So we have 180 times 2. And then we need to add 60 to that. That gives us 420. So 420 right there. And then we have we're going to have 270. So we will take the 180 and get rid of that. We have 270 times 2 plus 60. That's going to be 600. And then we're going to have 360 times 2. So 360 times 2 plus 60. That gives us 780 degrees. The y values are a little bit easier to figure out. Negative 2 times 1 is negative 2. Negative 2 plus 3 is going to be positive 1. 0 times negative 2 is 0. Plus 3 is going to be 3. 420, or -1 times -2 is going to be +2. Positive 2 plus 3 is going to be 5. 0 is going to give us 3 once we plug that in. And then when we plug 1 in, we're going to get 1 again. So we have these points. Now, you might be looking at how did I get these how did I get this interval over here? Again, what I did was I kind of looked at what's my smallest, what's my biggest, and since I know that I was adding 60 every time, I figured if I made every unit or every piece 60 degrees, that would work out best. So we have 60 degrees in 1. We have 240 degrees in 3, so that would be right here. We have 420 degrees in 5, which is right there. 600 degrees in 3, so that's going to be right there. 780 degrees in 1, right there. And you go ahead and connect your points with a smooth curve. Again, no V shapes here. And then you have your graph. And so again, you don't want to forget that you have these reflections here if there is a minus sign in front of the number that represents your amplitude. And then finally, the last equation we're going to look at here is a tangent function that is 3 plus 3 times tangent of 3 times x plus 30 degrees. So horizontal shift, still the same type of thing here. You look inside these parentheses, you see it says x plus 30. That means we're moving left 30 degrees. You have a vertical shift of positive 3, so we're going up 3 units. We have a vertical stretch of positive 3. That's remember, tangents do not have amplitudes. It's our vertical stretch. That is that number right there. And then the period of tangent is typically 180 degrees. So we have to see what's happening here. We are multiplying by 3 right there. So that means, again, since x always lies, we're going to divide by 3. We find out that the period is now 60 degrees. The domain, we'll figure that out in a second. The range is going to be -infinity to infinity. And the reason I say we're going to come back to our domain is because we kind of need to figure out where our asymptotes are in order to figure out what the domain is. So we have our points here for tangent. Again, it is asking us to graph 2 cycles here. So I have gone ahead and I wrote out 2 cycles of the parent function tangent. Here's 1 cycle, that's 1 period, and then from 180 to 360, that's another cycle. And again, to figure out where our new points are, we're going to need to find our mapping notation and then use that to find our new points. So the x values, we are dividing them by 3. So that's going to be 1/3 x. We're moving left 30 degrees, so we're subtracting 30. And then for our y values, we are stretching them vertically by 3 and then moving it up 3. So we have this mapping notation. I'm going to pull out the calculator here again, just, so that we have that available for us. We have 1/3 times 0, that's 0. That's minus 30, that's going to be -30. So our first point has an x value of -30. Half or 1/3 of 45 is 15. 15 minus 30 is going to be -15. 1/3 of 90 is 30. Minus 30 is 0. You can kind of start to see a pattern here, and it's going up by 15 each time. So this next one's going to be 15. Then we're going to have 30. Then we're going to have 45. And then we're going to have 60. 75, then we're going to have 90. And then I believe we have to go a little bit further. So let's see. We have 1 period right there. And then we're going to need have another period here that goes from 30. Nope, that's good. 30 to 90 is 60 degrees long. So that should be all of our points that we need. So let's see, we have -30, figure out this y value. You look at 0, 0 times 3 is 0, plus 3 is 3. 1 times 3 is 3, plus 3 is 6. Undefined is still undefined. -1 times 3 is -3, plus 3 is 0. 0 times 3 is 0, plus 3 is 3, and then we're going to have 6 again, and it's going to be undefined, and then we're going to have 0 and 3. And so if you look at that, you can see we're counting by 15s, so we'll just make every line 15 degrees. So that would be negative 30 right there. That's 30, 60, 90. That's about as far as you need to go. And then where are the vertical asymptotes? The vertical asymptotes, we have one at x equals 0. So we will make that a dashed line and then duplicate that because we have a second one here at 60 degrees. So we have our vertical asymptotes. Then we have negative 30 and 3, which is right there. We have negative 15 and 6, which is right there. We have 15 and 0, which is there. 30 and 3 there, and then 45 and 6, 45 and 6 there, and then we have our vertical asymptote, and then we have 75 and 0 and 90 and 3. So you then connect the points with our tangent graph. Like so. And that gives us 1 and 2 cycles. And so again, to finish out the characteristics of this graph, we see that our asymptotes are at 0 degrees plus every 60 degrees, so 60 degrees in. And our domain is going to be all x not equal to 0 plus 60 degrees in. So again, there's nothing new today really. We are just tying in all the transformations into single equations or single functions so that all the functions are having all of the types of transformations occur to them. I am hoping to be back on Wednesday. Wednesday and Thursday will be practice days we are still having our quiz over this and the other material. On Friday, I will be posting the review so that you can also start looking at that over the next few days. Please come to class on Wednesday with questions, and I look forward to being back with you guys so that I can answer your questions.